Okay, so there was a slight disruption. Anyways, let us come to that question. Uh, where were we? Yeah, we were. Yeah, we were here. Okay. So what I was trying to tell you is, second. Yeah. So 4,000 divided by 400 will be equal to k, and that gives me k equal to 10. Okay. This k equal to 10, I'm going to put it in this formula. So this becomes r is equal to 10 times s square. Now this is the formula which I'm going to use, or this is the equation rather, which I'm going to use to find out these two answers. Okay. So what is r when s is equal to 30? So r will be equal to 10 times 30 square, which is nothing but 10 times 900, which is nothing but 9,000. And the unit is r is in newtons. So 9,000 newtons. So that's the answer for this one. Then you have to find out s when r is equal to 6250. So again in this formula I'll put 6250 equal to 10 times s square. Okay. This happens to be 6250 upon 10 equal to s square. Okay, so this 10, this 0 and 0 cuts. So I get s square equal to 625. That gives me s equal to 25. And s is what? The unit is meter per second. So these are the two answers. Okay. So when the speed is 30 meter per second, the resistance is 9,000 Newton. And when the resistance is 6250 Newton, that time the speed is 25 meter per second. So these are the two answers. Okay. So that that was question number 15. And let us work out question number 16, the last one. Okay. Yeah. Now, this last question, question number 16, is slightly different from rest of the questions that we did so far. Okay, it's slightly different. Okay, it's a rather a logical question. Okay, you have to apply some logic to get to the answer. So 16th question says that a road research organization recently claimed that the damage to the road surface, okay, was proportional to the fourth power of the axle load. Now suppose D is the representing the damage. So I'll write here D is the damage to the road, and suppose L is the load of the axle. Load of the axle, okay, of any vehicle. Okay, so damage and load, damage and load. The relationship given is the damage is directly proportional to, it is written over here, the damage claims that the damage to the road surface was proportional to the fourth power of the axle load. So L raised to 4. Okay, this is the relationship, right? Now he has asked you this question is slightly different. Okay, so damage is directly proportional to L raised to 4. Okay, now he is talking about two types of vehicle. One is something called as SGV and one is a car. Okay, these are the two vehicles. Now what he is saying is the uh, damage caused by the HGV is 15 times that of a car. Okay, the axle load of the HGV is a heavy vehicle. Okay, so you can write here L, the load, okay, axle load of a HGV is equal to 15 times the load of a car. Okay, this is the relationship given to you. Now I'll show you where it is written. That, see here it is written, the axle load of the 44 ton HGV. Okay, so this is a HGV whose weight is 44 ton. So the axle load of this 44 ton HGV is about 15 times the load of a car. So can I write this L HGV is equal to 15 times L car? Okay, because L is representing the load of the axle. Okay, fine. Now what he's trying to tell you is what he's asking you is calculate the ratio of the damage to the road surface made by a HGV road and a car. Now he is asking you to find out the ratio of what? He's asking you to find the ratio of the damage caused due to the HGV and that due to the car. So in short, he's asking you to find out D HGV, that is the damage caused by the HGV, upon damage caused by the car. This is what he is asking you. Is that clear? Okay. Now, this is what the question is asked. Okay. Now, coming back to this relationship. Now, we know that D is proportional to L raised to 4. So, can I write that D for HGV will be proportional to L for HGV raised to 4, and D for car will be proportional to L raised to 4 for a car. Okay, because this relationship says that. Okay, now you are asked to find out this, that is the ratio of the damage. Okay, so this implies that the damage of HGV upon the damage caused due to car will be proportional to, now these two are left hand side, so these are right hand side, so it will be L raised to 4 HGV upon L raised to 4 car. Okay, now suppose I remove this now this is a, as I told you, this is a very logical question. Okay, when these two are proportional, this two also has to be proportional, but then there's a relationship between these two. Okay, what is that relationship? The HGV of the load, axle load of the HGV is 15 times that of the car. So this thing I can write as 15 into L whole raised to 4, okay, upon this will be L raised to 4. Okay, right? So this works out to 15 raised to 4 into L raised to 4 upon L raised to 4, and L raised to 4 will cut out and you will be left with 15 raised to 4 upon 1. So the ratio of this, the damage caused by the HGV to the damage caused by the car to the road surface will be 15 raised to 4 upon 1. So the answer is 15 raised to 4 works out to how much, you know? 15 into 15 is 225 into another 225 upon 1. Now this should work out to how much, you know? 15 225 into 225 should work out to, I think it is 50625. Okay, it's 50625 is to 1. So your final answer is your damage caused due to HGV, the ratio of damage caused due to HGV to the damage caused by the car is equal to 50625.1. This is the answer. So this ends our exercise 10, in which there were 16 questions and we completed all the 16 questions. And in the next video, I'll be starting with exercise 11, which is pertaining to inverse variation. Okay, so that's all for this video, and see you in the next video sometime in the future. Till then, goodbye and take care, all of you.